Hi guys, this is Mrs. Waymeyer. I'm going to be talking to you today about prime numbers, composite numbers, and factors. This is going to be getting us ready to work through prime factorization and being able to take a number, any number, and break it down to its prime factors. So before we can do any of that, we kind of have to know some vocabulary in order to be able to kind of understand what we're talking about. So when we talk about prime numbers, a prime number has only two factors, one and itself. So for example, if I were thinking of the prime number 3, the only numbers that I could multiply to get 3 are 1 times 3. Therefore, it makes it a prime number. A composite number has more than 2 factors. So thinking of a small composite number would be 4. The factors of 4 are 1 times 4 and 2 times 2. It technically has 3 factors, so it is a composite number. Factors are the numbers that we multiply, sorry, that's hard to read, to get a product. So if I were looking for the factors of 24 or 16, I'm looking for factors. Those would be numbers that I'm going to multiply to get that number. So in order for us to find our factors a little bit faster today, we're going to use a strategy called factor rainbows. And so I'm going to use the number 24. Okay? So whenever I make my factor rainbows, I always want to try and start the biggest and do the biggest arch. So whenever you see a rainbow, they kind of work their way in, starting and it starts really high and it has an archway. So the first 2 factors that I always start with, no matter what, are 1 and itself. Because no matter the number, it's always going to have 1 and itself. Of course, except that exception number 1. Which we've already talked about. So then I kind of work my way towards the center, trying to make sure that I get all the factors of 24. So I think to myself, okay, what's the number that comes after 1? 2. Is 2 and something a factor of 24? Yes, 2 times 12. What about 3? Can I multiply something by 3 and get 24? And the answer is yes. So I have 3 and 8 are also factors. What about 4? Yes. Hopefully you're saying yes. 4 and 6 are factors. Then the only digit that we actually have left in our number line sequence would be a 5. Can we take 5 times something to get 24? The answer would be no. So then since we've worked our way from the outside in, if we haven't made any mathematical errors, we should have all the factors listed right here. So 24 has, there's 4 on this side and 4 on this side. So 24 actually has 8 factors. So going back up to our vocabulary up here, does that make it a prime number, only 1 in itself, or a composite number having 2 or more factors? So it is a composite number. Okay, so let's try one more. This time we're going to use 36. Again, I'm going to start with my farthest factors. Hopefully I gave myself enough space. 1 and 36. I know that 36 is a double, so I'm going to use 2 and 18. Okay, so be careful. Some students forget about their 18s and their 15s because they're bigger than 12s. So it can be any factor, any way that we can get that number. 3 and 12 get us 36. 4 and 9 also get us 36. 5, no. 5 times something does not get us 36. But 6 times 6 does. Now here's where some people differ. Some people would write 6 and 6, but really 6 is only going to count as one factor. So what I like to do here is when it's a double, I just like to make a little loop-de-loop and show that 6 times 6 is 36. Because here in a moment we're going to count up our factors and we don't want to count this number twice. So I notice that I have, let's see, 5 and 4. So 36 has 9 factors. The reason that it has an odd number of factors, remember, is because we had a double, same number, 6 times 6. And so again, this is an example of a composite number. Hopefully that helps you kind of understand factor rainbows and how you can list out factors for numbers and what the difference between a prime and composite number is. Thanks for watching.